All right, everybody, this is 9.3, factoring and applications. So the first half of our lesson today, we're going to just review a bit of what we covered for 9.2, and then we're going to also add some application problems. All right? Okay, so last time we talked about how to factor something that looked like this. This, again, is a quadratic trinomial. Again, all of your problems are going to look like that, where it looks like ax squared plus bx plus c, okay, where a, b, and c are any type of numbers. All right, so typically all your problems will be like that, except for our last lesson, and we'll get into that when we get to it. All right, so first thing that we did is we want to see if there is a greatest common factor. Okay, so we look at these three and say, is there a greatest common factor? And if we have 5, the only thing that goes into 5 is 1 and 5, but 5 doesn't go into 26. So, and we can't take out any x's because we have a constant, and there's no x's that we could take. So there's no greatest common factor. And the next thing that we covered is to do glasses. That's where we find the two things that multiply and the two things that add. So they need to multiply to what we get from our glasses. That gives us 25x squared, and then it needs to add to give us that middle term, so negative 26x. All right, so one of the things we talked about is if we're stuck, we can always write down factor pairs. We want to focus more on the multiplication, and then from there we'll come up with our addition or subtraction. So we could do 1 and 25 or 5 and 5. Those are your only choices. Again, we talked about how to come up with those factor pairs. You just grab your calculator if you need to, and just do 25 divided by 1, and that will give you 25. Plug in 25 divided by 2, it won't give you a nice number. You could try 3, 4, you get 5. 25 divided by 5 gives you 5. Okay, so you just, again, we do 25 divided by 1, and gives you 25, so that gives you one of your factor pairs. And then 25 divided by 5 gives you 5. So again, that's another factor pair, is 5 and 5. And which of those would maybe give us a negative 26? So there's no way you could use 5 and 5. If you did both positives, you'd get 10. If one was negative, you'd get 0. If both were negatives, you'd get negative 10. So those are like your choices, and that won't work. But 1 and 25, that would work. They would both need to be negative, though. So negative 1x and negative 25x. And then negative 1 times negative 25, that does give us a positive 25. Okay, so after that, we talked about how we could take 5x squared, and we're going to take that let me highlight that. Okay, so this is the same as this, and we broke that into two parts, so we're going to substitute that in. So negative 1x squared minus 25x, not squared, sorry, I didn't mean to say squared there. Okay, and then we have that plus 5 still. All right, so basically we just took that and broke that into two parts. We now have 4 terms. So if we have 4 terms, then we can do what we did for 9.1, is we could plug those into these boxes. And then we took out the greatest common factor for each row. So what goes into 5 and 1 would be 1. We don't have a leading negative, so, and then for our variables, we could take out an x. And then for the next row, looks like we could take out a leading negative and a 5. And then for the first column, looks like we could take out a 5 and an x. And then the next column, looks like we have a leading negative, and the greatest common factor for the numbers would be 1. And we can't take out any x's. So just remember, we always have to take something out. Okay? So that's why we have to write the 1 there. And then we wrote down each of those, like the thing on the top and on the side, those are your each of your binomials, so x minus 5 and 5x minus 1. I haven't mentioned this, and I probably should have mentioned this in the past, is it doesn't matter which parenthesis or which binomial goes first or last. So if you wrote it like that, that's great. If you wrote it like this, that's just as good. So these are the same. Okay, because under multiplication, it doesn't matter. 3 times 4 is 12, and 4 times 3 is 12. The same sort of thing. Doesn't matter what order you do your multiplication. Okay. All right, so that's that. We'll do a couple more of these. If you are like so good at that, because we spent a lot of time on our last lesson, you're welcome to kind of scoot down a little bit till we get to the word problems. So again, we'll see if there's a greatest common factor. There's not, so we'll do our two things that need to multiply and add. So this one needs to multiply to negative 6m squared and needs to add to give us that middle term. Factor pairs for 6 would be 1 and 6 or 2 and 3. Ooh, so this is a tricky one. So 1 and 6 can give you a 5, and 2 and 3 can also give you a 5. So it has a lot to do with just the sign. So we know that one of them has to be negative, since we're multiplying and you get a negative. So I think the only way you could make 5 with 2 and 3 would be if they were both positive. But then there's no way you could get that negative 6 when you multiply. So it's going to have to be negative 6x, or I guess m, and a positive 1m. And that satisfies both of those for this puzzle. So you multiply, you get negative 6. You add, you get negative 5. Okay, so again, this goes here, and this goes here. And then these two things that we broke up, so we took that 5m, negative 5m, and now we have these two different numbers, so negative 6m and 1m. Those go in here for the remaining boxes. All right, so now we do greatest common factor, 2m, 1m, and we have a leading negative, and 3 goes into both of those. So we got 2m plus 1 and m minus 3. All right, so there's just a couple others. I'll probably just save those, maybe at the very end if you want to watch that. Okay, so let's talk about application. So it says the square of an area, the square has an area of x squared plus 10x plus 25. Write an expression in terms of x for the possible length and width of the square. So we want to find what the length is, we want to know what the width is. Okay, so cool thing about these types of word problems is they're exactly the same as the problems that you got above. Okay, so basically we're going to take, let's just look at this example at the top. Maybe that was our area for A. When you're all done, you're going to end up getting these two parentheses, and they're being multiplied, so that would be like your length. This could be your length, and this could be your width. Okay, so that's kind of what we're going to look for, is we're going to factor this out. We want to say, is there a greatest common factor? Nope, so now we can go straight into classes. So we need to find two things that multiply to give us 25x squared, and add or subtract to give us 10x. So the factor pairs for 25 are 1 and 25, or 5 and 5. So the thing that would make that work would be 5x and 5x to give you 10x. And if we multiplied, we'd get 5x times 5x gives us 25x squared. So that works, okay? And now we'd maybe use our box. Okay, we know that this goes here, and the 25 goes here. And again, we're going to take these two. That's the 10x. So 5x plus 5x is 10x. So we'll do 5x and 5x. And then greatest common factor for each row and column. So we could take out an x and a 5, and an x and a 5. So our answer would be x plus 5 and x plus 5. So then for our length, we could say that could be x plus 5. And the width could be x plus 5. And it's a square, so that makes sense that they're the same. All right, so here's another example. The Johnsons are putting in a fence in their backyard, but they're very, very picky about the ratio of fence dimensions. I mean, come on, wouldn't everybody? They want to make sure that the area of their lawn is always represented by this quadratic, x squared minus 4x plus 20. What expression could represent the dimensions of the fence? So dimensions like length and width. Okay, so again, it's the same sort of thing. We'd check and see, is there a greatest common, I'm going to put this 20 over here. Probably should have fixed that. All right, is there a greatest common factor? Nope. Okay, so what we'll do is we'll do our glasses. We need to find the two things that multiply to 20x squared. So that's the glasses part. When you multiply those together, that gives you 20x squared. And then needs to add or subtract to give us the middle term, negative 4x. So maybe want to write down like your factor pairs for 20, like 1 and 20, 2 and 10, 3 doesn't go into it, 4 and 5, and then next will be 5, but we already have 5. So those are all the factor pairs, and we need to make it so that it would give us multiply to 20 and add to negative 4. I think I made a mistake. Dagnabbit. So I don't think there's anything that makes that work. So 1 and 20 could give you 21 or 19, depending if it's positive or negative. 2 and 10 can give you 12 or 8. And 4 and 5 can give you 9 or 1. So it looks like Mr. Warner messed that up. Dagnabbit. Okay, I'm sorry about that. We're going to have to make an audible and change something up. So how about we say, why don't we change this to be, instead of a negative 4, let's call it negative 8. Okay, so what would make that work? It would have to be the 2 and the 10. We'd have to do a negative 10 and a positive 2. And that would give us that negative 8 that we need. And if we multiplied, oh, dagnabbit, then that still wouldn't work. Okay, gosh. Oh, Mr. Warner. Okay, let's just restart. Let's do how about we do 4? That should work, okay? All right, so we're going to do this again. So it needs to multiply to give us 4x squared. So that comes from multiplying that. And then needs to add or subtract to give us a negative 4x. Okay, so factor pairs for 4 is 1 and 4 or 2 and 2. So it's going to have to be 2 and 2, but they'll both need to be negative 2's. Because that would give us negative 4. And then negative 2x times negative 2x will give us a positive 4x squared. Okay, so then we would put that into our box that we do. So we already have that x squared and that 4, and then these are the two things that will fill in the rest of those boxes. And then we just need to find the greatest common factor for each row and column. So we got x, negative 2, x, negative 2. So again, we'll end up getting x minus 2 and x minus 2. So our length could be x minus 2, and the width could be x minus 2. Okay? All right, sorry about that. I'm not sure. I'm going to have to look at that again and see what happened there. All right, we'll see you guys.